Welcome to Minden here. As you probably have figured out, for those of you, okay, so one more question, if you don't mind. How many of you have about 200 hours or less in gliders? Okay.
Yes.
Half? And the rest of you are more than that. Okay, good. So I take it those of you that are under 200 hours, are you new to gliding within the last 2 or 3 years or so? Did you say? Okay. Okay. Good. Well, as you probably have figured out by when you do gliding, gliding is very different than power plane flying. I am not a power pilot. I only have my glider rating. I started flying when I was 14 at the Ames Soaring Club down in the San Francisco Bay Area at Hummingbird Haven. You know, that area that's right next to the Lawrence Livermore Lab. It used to be. And then it got consolidated into the NCSA, which now is out at Byron. And at the time, this is the mid-70s or so, you know, there weren't all the distractions of, you know, electronic devices and other things, right? It was pretty simple back then. And obviously there's a lot more distractions for our young people, which is to some degree our detriment here in soaring. But I started off that way and got flying here. I came to Minden my first time in 1975 for a wave camp then, and have been flying pretty much ever since, except for about an 8-year gap when I was you know, getting my career going. So I live in the San Francisco area. Work in high tech, and over the last 10, 12 years or so, I've really focused on both sharing the flying experience, not only with other fellow pilots, but non-pilots, in the form of presentations and then dual mentoring. I have an ESH 25, which is a high-performance two-seater that I fly out of Williams, and I've been a partner in it for the last 6 years or so, and I figured out the other day, taken up about 60 people in the front seat, of which about 50 of them are my target, which is like young cross-country, young meaning you don't have a lot of hours, cross-country pilots, so that you can learn about what it takes to go cross-country. You know, one of the issues for us in soaring is that the marketing of soaring is not, you know, we give people rides and do loops and things like that, but of course that's not why we are all here. And it's, of course, tough to get that concept across to people that you can fly 1,000 miles in a day. How high do you tow, to the moon? No, you know, and then you got to explain it all that, and I'm sure some of you have done that. So, I'm just glad to see you all here. This is my, what, 4th, 5th time, Lori, at Wave Camp. I've been as many as you've had up. And I'm glad that Lori started this tradition up again. This was in the 70s and 80s when this was big, there would be like 80 gliders out here. This is at the peak of soaring was 1986 in terms of membership and all. And those wave camps in those days were just enormous. It would just take over the whole field. Obviously, it's shrunk since then. So, thank you all for coming here. My presentation style, this will be a more casual one. I have about 20 soaring-related presentations. It could be working ridge lift, it could be flight analysis, it could be weather forecasting, things like that. So, and I could talk for 6 hours, but I don't think you want me to do that. But I have done that. So what I wanted to do right now is just cover some of the just clouds, because to me, half the reason I fly is because of the clouds, because it's much more boring to be flying on a blue day you know, some of the competition pilots. I don't fly in competitions. I've flown in some, which I think is a great way to learn. That's not what keeps me going. What keeps me going is cross-country flying, particularly when there are clouds, because not only do they give you the visual feedback, but usually you go a lot faster when you have some kind of indicator as to, you know, where the lift is and where the better lift is. So I just wanted to share some cloud pictures and just get you thinking about what you see and all, because to me there's so much information in all in cloud, there won't be a test. We'll go from there. So, I'm sorry, what's your name?
Eric.
Eric. So if you could just hit the, you'll be my, I don't have a remote.
What do you want?
Go to, well, before you go, when I ask you, if you could just go to the next slide. So, most all of these are pictures that I've taken.
Just hit
And, yeah, or the space bar, but not yet.
Is it time?
So, this actually, just so you know, when I was at the Portland Club, I was asked to be a speaker up at the Portland Club in 2009, 2010. I put this together actually for that because Steve and the rest of them told me, you'll be giving an after-dinner presentation, Kempton, but don't make it too technical. I said, okay, well, how about just a bunch of pictures of clouds? Cool, good, we'll do that. So, I selected this one. So, this was taken, I had an ASH 26E, a motor glider, single-seat motor glider, from 2002 to 2007. And what that allowed me to do was a lot more free cross-country, meaning it's not so much that I would have the engine to start me when I was low, as much as it was I could then motor from the Bay Area up to here, launch the next day, go someplace wherever I land, spend the night, and then launch the next day and go from there. So I had a number of great flights, and I have a whole set of presentations on those. But just to give you a feel for what you can do if you continue to hone your game, and then you do get something like a motor glider, is I flew on July 3rd one time from here to Steamboat Springs, Colorado. That's about 700 miles away in thermals. And it just so happened that year, were you here for Gordon Betker's talk? Okay. Gordon had flown his Kestrel like 3 months before, 4 months before, also did Steamboat, but both of us did not know we'd wind up in Steamboat. That's kind of just where the weather was. And I land in Steamboat, and he goes, the airport manager goes, there's another glider that landed here. He was also from Minden. I go, I know the guy. Yeah, he's a friend of mine. You guys do this often? Oh, no. It's lucky when we can,
Every Sunday.
That's right. So that's the wing you see of the SH-26E. And in this particular case, you can see I'm above the cloud base. And this day here, this was about 2006. There was a super hot day. I mean, it was record-breaking heat. There was a ton of fires along the Sierra. But when you have what I call those outlier weather phenomena, if you're ready for it, like that one, it was the hottest day of that year, and there was moisture, and if you can work it, you know, that's when you get those 30, 40, 50, 80% gains in your distance. Right? The weather is our engine, and if you can learn to read the weather and anticipate it, and then fly the weather that it is, you can, you know, you've been doing 200, 300-mile flights, and all of a sudden, boom, you do a 500-mile flight. That's in part to the weather. Okay, obviously, your piloting skill too. Next. So this picture was taken here from Minden. This actually was taken from a hangar over here. And this actually was the day before I did that straight out to Steamboat Springs. And so when you have, this is classic thunderstorm structure, you've got that wonderful updraft, but then of course you have the downdraft. And if you do a search on the web for my name and thunderstorm, you'll find a story about when I was sucked into a thunderstorm. And I got a whole presentation on that, we won't go into that. So if you read that, that was in 2003, and it is usually about, how many of you are power pilots? Oh, quite a few, okay. Well, you know what flying into, you know, VFR into IMC means. And it usually has about a 90% fatality rate. And I did not have, you know, blind flying instruments, and I almost, you know, wasn't here, but I got through it. And the point of that story is that these storms, especially around here, they're not as big as what you find in Kansas, but they can be very powerful. And if you can tap into that power, it is fantastic. Especially east of here, you get what I call small thunderstorms, maybe 3 to 4 miles across, with like an 18,000-foot base. When you get that just that Goldilocks moment. You got 18,000-foot small thunderstorms, a little bit of virga coming out the bottom. Those are like 1,000, 1,200 kilometer days where you can have that. The problem is that sometimes they just get a little too strong and you get sucked up. My GPS trace on that flight showed a 30-knot updraft, which is off the scale for all of our experience. I'd never before or since seen a 30-knot updraft. So, next. So this picture was taken, how many of you flown at Tehachapi? You do, okay. So you recognize, I don't know the name of that mountain, it's the one, you know, right as you're going into the Central Valley, it's west of Tehachapi. This particular day I had flown down the Central Valley, getting to Tehachapi, and then followed this cloud in, because I was actually trying to go to what I thought might be a wave point, and it didn't turn out there was wave point. But just to me, this was such a perfect, you know, visual on how you've got the hot Central Valley, if you could hit the space bar there, and it's coming right up the slope into that cloud, and that trigger mechanism, which is the west side, we're looking west, on the west side of that ridge there, you got that nice big broad valley out there, it's nice and hot, and then you've got this trigger point of the mountain, and it just goes right up there. So, to me, it's when you have examples like that just very clearly show how that cloud is been triggered and attached to that mountain. So you'll be starting to look for this as you fly, is looking for, you know, how does the ground structure for whatever it is couple to whatever cloud structure I see. Obviously it's tougher when there's no cloud, but by doing this, and you start to think about it and visualize it, and you know, as you're driving along, you just look up at these ridges and think, well, how would the air go up that? Have any of you been to the CNVV in France? Anyone? No? Okay. The CNVV is French for like the Center for Cross-Country Soaring Excellence. It's in Saint-Aubin, France, and in the is it right down there with all the lavender? Southern
Provence.
Oh,
Provence, thank you.
Provence, yeah.
I've only been there twice, I can't remember it. If you ever get the chance, I would highly recommend going there. It is not only a beautiful place and fantastic food, great to bring the family, but also they have, you know, these enormous hangars with, you know, 40, 50 gliders, Nimbus 4s and 25s and 27s and Discuses and all kinds of stuff. And you stay there for a week and you do some dual time with the instructors. And because of the way the Alps are structured there, they will run you right against the rocks and teach you how to work the rocks. Because we don't have really anything in this country that does that. And for you to be safely comfortable with working the rocks, because I wasn't until I was over there, so that you could be on this ridge out here and be comfortable, you know, 100 feet off the rocks and working along to catch the updraft. Once you get that kind of skill set with you, your soaring skills and confidence just take a step function up. So if you have a chance, I would highly recommend that. Got a little off topic. Okay, next slide. So this was that same day. This was taken about an hour and a half before that previous picture. So now I'm heading down the Central Valley. So I think it's pretty obvious. Can you all see this, the dust devil in this picture? Okay? You can get the space bar. So, I mean, that's a big one. That's a really big one. But the point here is as you're flying along, right, you're looking at the cloud structures above you, but you're also looking for ground clues. It could be, you know, a dust devil, which is obviously probably the biggest ground-related airflow structure. It could be, you know, tractors, dust plumes that go like this, 90 degrees to each other. Right? It could be flags, it could be smoke, it could be a number of things. It could be a fire. I base out of Williams in the northern Central Valley, and so in the fall time when they're burning off the rice fields, that has saved me a couple times when I fell off the ridge and I'm coming back and trying to get back, and yeah, your eyes water and you're coughing, but hey, it's better than landing out. So you can climb things. So you want to be, you know, aware of lots of things in your environment, including things like these dust devils. Now, another thing. So what else in this picture would tell you about a preferred direction that you want to go?
The clouds.
The shadows.
Right, the shadows, right. So you're always looking at these shadows, to give you a feel for those clouds, because sometimes you can't really tell. You know, we as humans, you know, haven't advanced much from the caveman days, cavewoman days, so to be able to judge, you know, how far away is that? You know, is that one behind that one? Cloud shadows. Basically. Next. So, one of my personal stretch goals when I'm flying out of Williams is right around late April, early May, when the conditions are right, you can fly from Williams, which is near Sacramento for those of you not from the area, all the way up to Crater Lake in Central Oregon and back, about a round trip of 500 miles. I've done that 3 times in the last 7 years, but it had to be an extraordinary day. And so these are the kind of clouds on those kind of days, because what I'm looking for is also that condition where it's just about to turn into some thunderstorm, right? That's when the cloud base is highest, the instability is greatest, and the updraft is strongest. And so when you see a cloud like this is what, when in the lingo, is like, this is a tall structure, right? When you look at a cloud and all of a sudden something sticking out of it, that's usually an indicator. This was taken around 1 o'clock in the afternoon. When you see that kind of shape, it means that there's probably going to be overdevelopment of thunderstorms later on that day. And the earlier you see that, the worse it's going to be. If you saw something like that at 10 o'clock, as we say, it's going to blow up probably by 2 o'clock. So you start, when you start getting more experience, you start, okay, yeah, these are the indicators. Okay. And when you're doing an out and return task, out and return is the riskiest task, right? Because for a given distance, you're the furthest away when you have to turn around. And having done enough out and return tasks, I can tell you, if you don't have a specific point in mind, and you're just going to kind of eyeball it, saying, well, I'll turn around when I think it's good. Well, the problem is it's the peak of the day, and you're feeling good, so you always think you can go a little further, and of course, you know, don't have to, you know, state the obvious. Every mile you go out is one more you got to come back. So, judging that for yourself, what you're comfortable with, is part of the whole cross-country thing. This is that same day that I went to Crater Lake. This is 2009, I think. So now we're coming back, and this is the Trinity Alps, if you know extreme northern California. It's west of Mount Shasta. Beautiful little area. It's only like 30 miles by 30 miles. The interesting thing about the Trinity Alps is it looks like the European Alps, and it acts like the European Alps. And when I say act like it, meaning if you go to the CMVV in Provence, France, the Alps are a classic situation where you've got the higher ground and it's sucking the air from the lower ground. The air goes up the opposite of drainage, typical for anywhere around here. And so these Alps act very much like that. So I've gone in there with my glider with somebody else and say, it's not normal to pull your dive brakes on a nice healthy day, but you know, I say, watch this, this is gonna work. Let me show you how this works. I pull the brakes and we drop 4,000 feet and go below the ridge line. Sure enough, you know, the air is wicking up the side of the ridges just like this, and you can just kind of hop along and, you know, you're back at the cloud base again. That skill set in terms of being able to work the rocks comfortably, again, is something that will really pick up your game. And I actually take some people into this area, usually when there's less snow there, to do that. The Trinity Alps, the highest point I think is just slightly under 10,000 feet. So you can just see eyeballing this, that, you know, these clouds are a good 4,000 or 5,000 feet above that. And this is an outlier kind of weather day. And also notice, remember I talked about the tall structure? I mean, it's pretty obvious what the tall structure is in here, right? This one has already kind of blown up into a thunderstorm, you know, with that cirrus coming off the top. And you can see just a little bit of rain coming out there. This, to me, for cross country, this is the Goldilocks situation, right? It's just a tiny bit of precipitation, but you got this nice, strong, high base clouds, and you can just cover a lot of ground. Ask any questions as you go along.
How does that relate to Goldilocks?
Well, Goldilocks was a glider pilot. That was in the epilogue.
That's right.
Yeah. So here's another tip for you. So
3 beers, I think.
Stuff them in at 232. So one of the important things to know about clouds is how can you tell a young cloud from an old cloud? You know how to tell a young cloud from an old cloud?
Typically the flat bottom indicating the
That's part of it, but that's not always true. If you fly out of Williams, there can be shreddy bottoms on sheer. Okay?
triangular section.
Could be that too.
Crisp or fluffy.
Closer,
Are they talking about younger or older?
meaning it just formed or it's continuing to form. Okay? So the answer is, you know, look at this picture, you can tell, look at how white, you know, it is at the tops and all. And yeah, it's dark on the bottom partially because it's in the shade. But the reason a fresh part of a cloud or a fresh cloud is new and forming is because when it goes from water vapor, right, we got water vapor around us, when it goes to that first little droplet, that droplet is extremely tiny. And so for those of you who remember your light physics, there's much more diffraction in a smaller droplet because of that tight radius. As the droplet gets bigger, there's less diffraction. So when you have lots of diffraction, what do? You get white. As the droplets coalesce to each other and they get bigger, there's less diffraction. So it's grayer. And so because we are looking for the freshest cloud, because it means the updraft is working it, that's one of your tips of the day, is that it's from, you got very small water droplets, and that's why typically the upper parts of the cloud are white. Obviously they're higher up too, so they don't have shade on them. But also, you've seen plenty of times when there are these, you know, two clouds equally sized, kind of small, but one's white, brilliantly white, and the other's kind of grayish and flattish too. So the point about the features on them, you know, when you've got nice, clear, firm features, that cauliflower look, it's definitely growing. When you're kind of flattish and flaccid and, you know, kind of like all of our bellies if we don't exercise too much, that's exactly how the clouds are. Okay? Next. Okay, now we're getting to some wave stuff. So when I had the ASH 26C, I was really into getting into doing some distance flying here in the Sierra Wave. I started in 2003, and in 2004, out of Minden here, I set at the time the longest soaring flight in the U.S., which was 1,024 miles. And of course, Gordon has stretched that to like almost 1,300 miles now. But at the time, it was fairly new to do that. So this particular day was in 2005. And I feel I've been very fortunate in my life, and lots of great opportunities in a number of aspects of life. And I don't have a lot of regrets in my soaring career, except for this day. This day was June 16th, the longest day of the year. Okay? And you need light to go far, it's daylight. And I had seen this day coming for about 9 or 10 days, and we can talk about weather forecasting a little later. And so my ship was based at Truckee, and I took off, and I was going to go to Susanville to start to attempt a 2,000-kilometer flight. And I took off, and about 45 minutes into the flight, I realized I forgot my water. And I'm going to be up there for possibly 10 hours. And of course, if you don't take care of yourself, your judgment can start to not be good. The day started forming, and I've never seen a day like this since then. It was a 2,000-kilometer day. So I went up to my turn in Susanville, went down to Olancha south of here, and on my way north, this is what I saw. This is slightly north of Mono Lake. This is that's just north as you climb out of Mono Lake heading north here. So we're looking straight along north. Minden and Carson Valley are another 80 miles or so. So wind is blowing from left to right. You kind of have this snow dust, as I call it. I'm not really sure what it is. Come down, kick up. So this is your classic lenticular here, and it is just, the way you make speed in cross country is when there's absolutely no doubt where the lift is, right? Because when you're having to fish around, that's what makes it slow. So when you're along the wave here, it was like, you know, maximum speed before the parts fall off and stay below 18,000 feet, and it was fantastic. Problem was, because of my lack of water, I got fixated on my declared turn points. And so I get up to Susanville, and I had picked a point that was a little too far downwind, but I went for it anyway, and I get there, and there's sink, I get it, but then by the time I got back out, I was too low over the Susanville airport, and I had to start the engine. And I started the engine, and of course that nullifies the soaring part of the flight, so I was just so distraught that I basically just went back to trucking and landed. I'd actually done an 1,100 kilometer out and return flight, and while it seems a little funny to say, it's kind of like, you know, it was this incredible off-the-chart day, and I blew it. So what I should have done, in case you all ever do this, is you say, forget that declared task. just turn around, stay in the lift, and keep going. Because at the end of the day, yes, we have badges, we have records, and all those things, but my personal philosophy is just stay with the lift so you get a fantastic long day, because there aren't that many super days. I mean, there's a lot of super days here, but you know, then there's the super day. And my guess was, I knew when I landed, I said, I'm not going to see another day like this for 10 years, and 10 years comes up next year, and I still haven't seen a day like this. So that's how it goes. Next. Next. So this is a time-lapse photography that Gordon, did you see this yesterday? This is Gordon's video. Okay, so you were looking straight west from here, so you can see the cap cloud, you know, right Lake Tahoe's on the other side, and then it's kicking up into this. So I believe if you just hit the space bar, you'll see this run, this video run. Yeah. So you can see, obviously, you know, stuff is forming here. This is about a 10x time-lapse photography. I'll be leaving this presentation with Lori, so you can, you know, run through this at your leisure. I can post it on Google Drive or something. So I personally love time-lapse photography of clouds because it allows you to see, you know, sped up what's happening, because obviously you stare at it, you know, it's kind of slow, but you do that and you start to see the dynamics in that, which as a sailplane pilot is good for you to think about, well, how does the wind influence this, and thermals are actually fairly rigid. I mean, they do tilt with the wind, but you know, the wind does not flatten them unless it's really blowing. And so it's amazing how rigid the thermals can be, and you could be circling here, and it's a bit stiff compared to the wind. To me, anything that will help me visualize how the air is flowing is a very helpful tool. You've probably all heard the analogy that wave is like water, you know, over a rock in a stream, and that's generally true for the layperson to tell them. But when you start seeing time-lapse photography, have you ever seen a time-lapse photography where you see layers of cloud and they're going like this? Have you ever seen that? Mm-hmm. I go, how is that possible? Unstable air is like slippery. And so when you have these different layers of air, and air layers much more than we think. And so you can have these layers just sliding right over each other, 90 degrees to them, or even 180 degrees to them. So part of thinking to yourself and proving to yourself that air is not homogeneous in many ways is a very useful construct, because how it's working where you were at next to the ridge is not the same how it is half a mile down the ridge, or you know, a quarter mile that way. And that's critical for when you're working close to a ridge, because a lot of times, you know, if you're not very aware of that, has anyone here talked about, you know, being too close to the ridge and getting thrown into the ridge, Lori or Russ? I mean, I know they're not going to get that close, but if you ever go down to the White Mountains south of here in the Owens Valley, the Owens Valley is the largest, the deepest above ground trench in the world. Obviously there's bigger ones in the ocean. But it's from average ridge lines at the bottom of the Owens Valley, it's the deepest trench. So the White Mountains are very famous, especially, any of you hang glider pilots? No? Okay. Well, you know the White Mountains, because there's a lot of them who jump off the White Mountains. You got these canyons going from the bottom, which is around 4,500 feet average elevation, to the top at 12 or 13,000. You have this 1.5 mile long canyon sucking this hot desert air there. You know, you can get 15, 18 knot thermals coming up that thing, and if you hit them with a glider, it's great. You know, you just blast on up to base. But if you happen to be along right next to the ridge, it can hit your outer wing and throw you into the ridge, which would really be bad. And we think that's what's happened to a few people when we just find the wreckage there and don't know what happened. So it's very, this area here, lots of energy, you know, both in wave and in thermal. So this is when HD cameras came out in the mid-2000s, I mounted at the time a big one like this in my cockpit just to run things, and had a tape in it. This is the instrument panel of my 26E. That's Mount Diablo over there for those of you from the Bay Area. And I'm heading south and crossing the Delta. Okay? So I'm only about 3,500 feet here, and if you go to my blog, the video of this is on my blog. And the lesson in this particular situation was, you always want to be looking out as far as possible. One of the things I love about flying is that on a good day you can see 50, 80 miles. So you can kind of see what's happening and adjust your course line to be able to hit the better weather. In this particular case, this actually is the same flight that the couple previous slides where we saw that enormous dust devil, and then the one with the big cloud over the Tehachapi Mountain. There was a variety of weather in that day, and in this case I had taken thermals from Williams, and now I got across the Delta. Oh, it's wet, and so it usually doesn't produce very good thermals. I'm coasting across, and I'm going, you know, it's going to be a little iffy getting to those clouds. Mount Diablo is 3,800 feet, so those are like 4,500 foot clouds, but that's a little far. So if you look closer, you see this. What is that? That is one of those peaker plants, you know, it's an electrical generation station powered by natural gas, got a bunch of jet engines in there to make power generators. I didn't see that at this point. But there's this little queue right here, right there, and that's off of that plant. And if you look at my trace, you can see I'm going along, and all of a sudden I realize finally it's there, and then I head to it. Next.
Is that heading south?
Yes, okay. It's heading south. So that is where I took that picture, and it's this. Okay, let's get the video's going.
Okay, so
Could you grab the remote to turn up the sound? Not transmitting it through. Oh, that's right, because it's VGA, sorry. No, you can turn it back down. Anyway, I'm making comments about that, and I don't notice that cloud over there. I'm just fixated on that smoke, which is very useful to tell me the wind direction, but I didn't even think about the power plant in this case.
Hello? You listening now? So you gonna stop the trailer too? Yes?
So you can see, you can tell by the flight test when I finally figured it out.
So let's see.
And I go over there. Now, I am in a motor glider, which sometimes can make you take a little bit more risks than you should. That's the queue up here.
And then you pick some.
Okay. And just below the nose, you'll see it in a second, is the plume from the power plant. There's the plume. Okay. Now, I did see what I thought would be a landable point next to the power plant. I never actually looked at it to see if it was landable, but okay. Because I can't quite make it to those further queue. So we'll see here what happens in a moment. We're still going? Oh, I think we're still okay. Well, I'll show that video separately. The rest of that video shows me actually hitting the lift there at about 1,100 feet and climbing at 3 to 4 knots, and there's some weird smells and other things, but you know, hey, I'm happy to get a climb. So this is a picture of Crater Lake on one of my trips up there. Have any of you flown south of here to Mono Lake yet? When you do someday, particularly if it's a thermal day, you'll start seeing from a distance, you'll look at Mono Lake, and at least for me, I go, something looks funny about that lake. And what it is that it's so smooth, you've got this miles and miles of mirror. So just like here, you get this reflection in there, and I thought, oh my God, look at that. You know, this enormous multi-mile long mirror, and except instead of this case, instead of a snow-covered banks, you have the clouds being mirrored in Mono Lake. And it's the weirdest looking thing. I mean, it's one of those things that only, you know, we will see as glider pilots. Because when you're flying over it in a jet, either you're too low of an angle, too high of an angle, or you're too far away to see it. Right? So we, at the particular altitudes we fly, it's actually just perfect for getting that kind of view. So hit the button there, hit, and once again, this is should be a time-lapse photography. So this is another one from a friend of mine, and he shot a 20x speed up. And again, you can learn all kinds of things from here. Okay, you can see the Q popping here. As things are getting moisture, you're gonna start to see what's called a Peleus cloud forming on top of the Q. The Q form push up into the upper level moisture, and it raises a little bit, just like a lenticular. And so you get that condensation on top. Stuff like this is just, to me, it's just fascinating to watch the way things form and all. So again, I'll be leaving a copy of this with you. You can download it and run this whole presentation on your computers just to get a feel. Oh, another thing, like things are propagating, even there's Q popping even under total overcast. Likely that would not have gone on because, you know, that's still the hot air that was warmed from when the sun was there, because that, you know, higher level stuff just cut it off. Again, so you keep thinking, okay, well, just because something's shaded, was it just shaded in the last 5 minutes? It might still have some hot air on it, for example. Next. So, Russ, have you and I talked about the hydraulic jump effect and wave and all? Have you talked about that with them? Okay.
Covered that yesterday.
Okay, great. So we talked about how wave, you know, you got your classic obstacle and the air goes like this, right? So that's classic. But what Russ and I talked about is those of us who've been involved with wave for longer realize that that's not the only mechanism that is wave-ish. There is also the hydraulic jump, which, you know, you probably had the example of, like, you've seen a spillway in the water keeps going and all of a sudden it reaches a non-laminar point and then, you know, kicks up. There's no obstacle there, it's just, it reached its Reynolds number or whatever it was, and so it kicks up. One of the other phenomena that happens is as the air comes down the backside, if it's a gentle enough wind and it's a warm enough day and it's unstable enough, you can have the phenomena where it comes down, right? Air is compressible, so it compresses, it can hold more moisture, right? That's why there's the gap between the clouds on the mountain and the wave cloud. And then it compresses, and it can often kick off a thermal. So this picture is taken looking down the Owens Valley, you know, looking straight south, and that's exactly what's happening here. So I'm in a wave lift, but it's not very strong, comes down, and the fact that that's not a rotor cloud and that's not a cap cloud, it's a thermal that's been kicked off there, and then it's being entrained as it goes up, and the fact that the thermal's going up is helping to help the bounce, if you will, go up. And as wind gets stronger across the wave, across the obstacle like here, the wavelength gets longer, right? Meaning from the top of the mountain to when the top peaks again. Makes sense, right? The fluid's going fast. When you have this kind of situation, you can actually have it where this is the obstacle, okay, and the wind's coming like this. If it's gentle enough and you have this kind of circumstance, it can go down and it can just almost go straight up and then sometimes even kick back on itself, which seems very strange, but these things happen. And I have been twice in the Sierras on a very gentle day, very gentle wind day, and I am only like a quarter mile or less away from the mountain, and I am pointing well below the ridge, you know, maybe 2,000 or 3,000 feet below the peak, pointing at this wall of rock, and you're going up. It's the weirdest thing. You're not, you know, 3 miles away from the ridgeline, you're like a quarter mile away from the ridge. So the point is that there's all these different mechanisms that, you know, we teach the classic stuff, but you have to kind of be open and read what's that cloud telling me. Okay? Next. But by the way, in this flight I launched from Cal City heading north. I got to about Bridgeport and then turned around. Again, very, very light winds. This was like October, late October or so. And the other weird thing is, look at that. That's like fog, but on the east side of the White Mountains. I've never seen that before. It's like almost spilling. It's weird. It looks just like fog. I've never seen that before over there. Okay, thanks. And this is that same flight. Okay, now I'm further south, right around Ridgecrest or Inyokern, for those of you who know that area. So if you look closely, you can see this gentle waviness here. Very gentle. But I see that and I go, yeah, well, obviously there's some wave happening. And you look at this stuff here and you go, what's that telling me? Well, it's organized enough that that's the gap. And there's another gap over here. But again, the winds were so light, there could be multiple foam gaps. There's not just this one gap. And I'm at 18,000 feet heading south. But the point is that things can get very complex, and sometimes you see weird things that you just can't even explain. I've seen a few of those, and you go, I don't know what's going on here. All I know is there's lift there, but I couldn't explain it. That will happen as you get more and more experience. You know, and again, the reason I'm sharing this with you is just to keep your mind open. We're all looking for these nice classic days, and those are great and they're easy, but sometimes it's not so straightforward, and you just have to have your mind open up to other possibilities. Out there, I mark the waviness. Any questions so far? Comments or thoughts? So this picture was taken on that 2,000 kilometer day, earlier in the day. I'm southbound. It's probably around 10 o'clock or so, and that's Mono Lake down there. And to me, this is one of those things that only we as glider pilots will see, because no power pilot in their right mind, given the forecast, would be out on a day like this. Because power pilots don't like wind, right? And so here I am, bombing along, and these lenticulars just start forming, these gossamer lenticulars, and the strange thing about cross-country wave flying, especially here when you've got these long lenticulars that run for hundreds of miles, is that if you do this long enough and you're next to the lenticular, and you know, so long as you stay on the upwind side of it, you get lift. I mean, you know, I'm somewhere on the Eastern Sierra. You kind of lose track of where you are. So long as you're in the lift and you're heading south, and the lenticular's on the left, and my nose is pointing south. And after a while, this only happened to me a few times. You go, where am I? Oh, okay. Oh, that's the long time. Okay, that's right. You know, it's not like you're lost, but you have been, your reference point have been these clouds for the last hour. And so long as you're doing 150 knots across the ground, and you're just bumping along below 18,000, and it's like you've gone to Mars for about an hour, because you are in a situation where you are referencing things that are not in our normal life, right? And I tell this to some people. I go, the only thing I can think of is as a scuba diver. When you're down there, you're referencing things in your environment which is not your day-to-day, not your terrestrial life. And that's how it is when you have days like this, and it's just magic. I had the privilege to take Lori up after you've been running this operation for 2, 3, 4 years. I take her up, soaring in a wave day like this, and I'm up there and I go, so you must see this all the time. She goes, this is the first time I've been up here. I go, what? I go, what do you think? This is incredible.
But it was more beautiful than that.
Yeah, and
because you went around the corner, there were these lenticular clouds, but you flew up around the corner, and they stacked up. You couldn't see it from the ground, but they just stacked up.
It looked like it went to the moon.
Yeah.
And this particular picture, I took this, and it's on the web someplace. I have gotten more requests for this picture. It's in the Bernard Ecke new cross-country book. This wife of a German glider pilot emailed me and said, can I have a copy of that picture to print for a Christmas gift for my husband? Whatever it is, this picture speaks to a lot of people. So I think actually this might be on my Facebook page. Anyway, so that's, but to me, these kind of events, no other person but you will see these, and you're going, as I say to myself, I'm the luckiest person on earth right now. So I hope you feel that way too. Next.
Can I ask you a question real quick about that? Can you explain to me, when you get stacked lenticulars, why it just isn't one solid cloud? I mean, how has the air become drier in between? Do you have any idea?
Good point, good question. Because you see, as people have stated, it's like stacked dish plates, right? And the fact, why isn't the front of that this one uniform wall? Sometimes it is, but when you get that dish plate look, obviously one little layer has slightly more moisture and is condensing slightly earlier, like, you know, a few seconds earlier than the other. Because if you watch the leading edge, it's very little time from the time it forms to the time it's with all the other, you know, cloudiness right there. So it's a very, very slight difference in moisture and or temperature. So, and like I mentioned earlier, the air layers much more than we think it does. And like I have to keep on reminding myself of that, even though I've been flying for decades. You know, air has lots of different subtle layers, and that's what you're seeing when you see that stacked lenticular look. The other thing, which sounds like an obvious statement, is the taller the stack, all other things being equal, the stronger the lift. And when you think about it, it makes sense because you need to have some kind of vertical action. And if that vertical action is through a larger section of the atmosphere, it means the trigger for that, whatever it is, you know, it's one like this with the air, has to have more force to it.
Okay.
I told that to one of my Australia friends. He goes, I never thought about that, but the Australians don't fly wave too much. But that's kind of been my observation. So that's why when you're here for a wave flight and you see this enormous stack off of Frio Peak, well, it's because it's Frio Peak. It's the biggest peak amongst the set here. The same thing with Mount Rose. Make sense? Next. So this, so you asked the question about why doesn't it form this more uniform wall? Well, that's what's actually sort of happening here. You don't see the stacked dish look here as much, you know, maybe a little bit of it up there. This picture was taken, this is Walker Lake here, so Minden is just another 20 miles south of here, looking directly south. This is the day, March 25th, 2004, that I did that 1,000+ mile flight. And so I had already got my first turn up near Susanville, or towards that direction, turn around, and I'm coming south now. So, and you can see it's early in the day by the shadows. This is maybe like 10 o'clock or so, 9:30. I'd actually had a difficult start, and I kind of was futzing around here for like an hour before I could get into the wave. But once I got going, it was fantastic. So, the interesting thing to note about this structure here is, so it's nice and classic on the upper part, and yet you see this kind of, you know, this junk down here. Well, as the day goes on and as the ground heats up, you're getting more burbliness and instability in that lower layer. And so as the day goes on, that lower lip will start getting rougher and have more stuff there because of the lower level heating activity. So the only time we want cirrus is on a wave day, because cirrus suppresses the ground heating, right? Now you don't want too much cirrus, because it's kind of a drag to have a heavy cirrus, and you're coming up to a lenticular, and then it kind of goes together like this, and you can't see where it is. So you like to have some cirrus. That's the only time we like to have cirrus as glider pilots, is to help us suppress that heating. So actually, those few pictures earlier, when I talked about that heating of the air coming down the backside, compressing it. This picture was taken. This is Cal City, for those of you in Southern California. That was my motor glider at the time. This is 2006, I think. And this was taken in the evening. My friend Jim Staniforth, he also had a 26E, so we both flew that next day. Sometimes, and you get, you know, lenticulars with that nice red sunset. Oh, I just love this picture too. This is also in one of the Bernadette books too. But a lot of times, the day before a really good wave day, you'll get super high level lenticulars that you can't get to because they're so high up, there's not really any lift between here and there. And that was kind of the case here. Those are maybe like 25,000 feet, but there was no wind on the ground. Next. So now these are not my pictures. So have any of you heard of the Morning Glory?
Mm-hmm.
A few of you? Right, well, the Australian contingent here I would expect would, but anybody else. So, the Morning Glory is a strange phenomenon in the Gulf of Carpentaria in Australia. One of the many reasons to go to Australia. I've been to Australia probably 8 or 9 times, been soaring there at least 5 or 6 times. Lovely people, fantastic thermal flying. The Morning Glory is a phenomenon where the air from the Coral Sea comes around and hits the Gulf of Carpentaria, and it essentially goes bang. Have you ever seen a wave if you're in a still pool of water and 2 waves come together and go, and then they go out. That's exactly what happens here, but on a very large scale, like hundreds of miles. And so that wave going back comes across the Gulf of Carpentaria almost exactly parallel to the coast. And it only happens, I think, in like October in the Australian season. And it's a weird phenomena, but you get, I mean, is that the weirdest thing? Those ribbon clouds, they stretch for hundreds of miles. But the key point is, unlike wave clouds, where wave clouds are stationary and the air is moving through the clouds, right, condensed at the front and dissipate at the back, these clouds are traveling clouds. So they move at 30 miles an hour, this roll cloud. It moves through the air. And so hang glider pilots and soaring pilots, there's, I can't remember what the name of the little town there, but it's way the hell out in the middle of nowhere. But all of a sudden, over the years, you know, these soaring people get there and they just sit there and wait, you know, and supposedly one of the signs is that if there's a lot of dew on the leaves in the morning in October, that's a sign. And it only comes across in like the early morning or so, like at dawn. And so you can get on the front of those, and they're only like 3,000 feet high, 4,000 feet high, and just ride the front of those, and they come inland, but then as the air warms and the instability starts breaking them up. But
Is there rotation in them, or is it actually rotating the air in the cloud or not?
I don't actually know. I've never seen a time lapse. It would be interesting to see a time lapse video. I don't know. All I know is that people just run up and down them, and but this whole thing's traveling. So pretty soon you're in 50 miles inland, 100 miles inland, and the residents of the towns in this area say it also makes a very low rumble as it comes across. So you can imagine, to me, weather phenomenon. I mean, it's weird enough that people mistake lenticulars for UFOs. But can you imagine being, in this town and you hear this rumbling and this long thing, kind of looks like, those enormous, county-sized UFOs that you see in, the modern, science fiction movies, except this is real and it comes over you. Next. So this shot was taken actually out over the ocean of a morning glory, and that whole front is just coming inland. And you can see how, it's kind of drawing up the clouds and starting to condense here.
Which way is it moving?
It's moving right to left.
Sorry,
I mean, you look at that going, God, and it's not very well known in Australia. I have a friend in Brisbane, which is in the Queensland territory, and I asked him, well, haven't you heard about the Morning Glory? No. So I pulled up a few web pages. This is in Queensland. Never heard of it.
How far off do they tow offshore to get into it, like towing somebody into a wave to surf?
Because it's only 3,000 or 4,000 feet high, obviously not too far unless you're really gutsy with a motor glider to go, and because usually it comes ashore around mid-morning or so, so I suppose you could go, 400 miles out, but of course it'd be dark when you did that. So, next. No, just another. So kind of this Lenny is kind of formed, this traveling Lenny is forming over it. It's the weirdest thing. This picture was taken in New Zealand. How many of you have flown in New Zealand? Just a few of you. In your soaring career, I mean, the fact that you're here, to me, tells me that you're pretty serious about soaring. To me, there are just two places, and the top two places for me to go are New Zealand and the CNBV. Partially because they're fantastic people, and the soaring's great, and it's a real mix of all kinds of stuff. But also, I mean, it's just beautiful, and the country's beautiful. This picture in New Zealand is New Zealand's positioned in what they call the Roaring 40s. There's a lot of wind and a lot of days and days of just continuous wind that is usually orthogonal to the ridgeline. And so you get these clouds and lenticulars that's just set up that just go, the whole length of the island and maybe both islands. And in fact, before the Germans started going down to the Andes and setting records there, this New Zealand was where the distance records were set. And in fact, the first 2,000-kilometer flight was set by Ray Linsky 25 years ago, and he ran up and down both islands in an Nimbus 2. So if you ever get a chance to go there, it's fantastic. So, any of you from besides you from Oregon, area flown in Oregon? Okay. So you recognize this, this is Mount Hood. And I had never flown a peak generation wave source before. I'd flown, along here, continuous ridge line. And one of the things I learned was that a peak generation source is exactly analogous to a boat and the weight behind a boat. So the wind is coming, so I'm looking south, southwest here. The wind is coming from right to left. You can see the cap cloud on Mount Hood. And you can also, if you imagine, if we had a satellite picture, imagine Hood as the bow of a boat and you've got this wake. And so now we're looking, again, if we're in a satellite looking down, this is the right wake here, and that's the left wake. And that's exactly what happens. And can't really see it in this picture. Well, I actually kind of can. You see how the cloud is kind of going like this here? There are a series, and again, if you watch a boat, for those of you, I can't stand boats, I get sick. But you watch the wave off, the bow wave off of the boat, and there's smaller waves in it. This is exactly the same, and so it just so happens that that bow wave comes right over the Hood River glider port run by Gary Boggs. And if you've ever met Gary Boggs, he's quite a character, and there's a whole nother story around that. But it's great because you can just take a 5-minute tow to the ridge, get up on the ridge, head straight into the wind, get one of these little waves in the bow wave, hop, 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 get up there, and this is the rooster tail. So, there's that water that comes around the boat, and that's exactly what that is. You get right in front of that, and guys are going to 28,000 feet that day. Very small, only like less than a square mile in size. But, I look at that going, God, here's this, in the scale of things, right, it's to me, it's just fascinating to see how some very small scale things, relatively, like a boat on water, and then you multiply that by what, 1,000x. And that's similar. So these constructs, to be able to just keep these in mind as you see water flowing and cigarette smoke and smoke from a fire and cloud formations and all. You just try to think, what's that doing? Why is it forming that? The most critical thing you need to be aware of when you are flying is where's the wind coming from? And that is on your flight computers, to be able to have a wind indicator and trust it, because not all wind indicators are all the same, to be able to know what's going on with the wind, because that is absolutely critical, especially when you're close to the rocks. But I just love this picture. This is in my motor glider. I was flying out of Hood River, and this is very common. This is May, but it happens in June, July, and all. And if you ever get the chance to go up there, it is of course beautiful. You got the Hood River there, lots of outdoor activities, and then you can have a flight into the Mount Hood wave when it's working. It's just fantastic.